This video is brought to you with support from my patrons on Patreon.
Hey everybody, it's Jimmy from the DIY and Digital, and today we're taking my most complex Arduino project and we're making it work a lot better. Welcome back everybody. About 2 years ago, I did the most physically complex Arduino project that I have done on this channel, the Arduino multi-block signal system, and I was able to implement it on my previous railroad and it ran fairly well. But recently I've talked with a couple guys over at Trainmasters TV and they were actually able to help me do some improvements to the code and definitely get it running a lot better, and I wanted to share that with you guys. So what we're going to do today is we're going to take the multi-block signal system, we're going to do some minor hardware modifications and some minor code modifications, and we're going to make it run a whole lot better. Let's get started. Now, as I explained last time, the Arduino does have USB and serial receiver and transmitter pins for communication, but we're doing really basic on-off communications here, so we don't need anything so complex. The basics of what we need to do is that when a block is occupied, we need the Arduino to tell Arduinos at the adjacent blocks that it's occupied so that they can let trains know through the signals. Now, previously I'd done this with a digital output and an analog input, and this worked, but it didn't work that well, it wasn't that consistent. So what we're going to do instead is we're going to do a digital output to a digital input. Now you got to make sure you have that shared ground as well, because that's what makes all of this work and connect properly. Now here are the parts that you're going to need. They are identical to the ones you needed for the previous version of this tutorial. You're going to need an Arduino. For this one, we're going to be using our old standby, the Arduino UNO. You're also going to need some LEDs, red, yellow, and green, and you're also going to need some infrared sensors. Then you'll need a bunch of DuPont connector wires for prototyping. Those are the parts you'll need. You'll also need a breadboard so that you can install everything in this in the prototype build. All right, let's get started. Now, it's going to be difficult to see exactly what I'm doing, A, because I have big hands, and B, because these are very small parts. So I've included a schematic to this entire thing in the description below. The first thing I'm going to do is put our infrared sensors in their positions on the breadboard, and you notice I have them split across 3 rows. This is just how breadboards work. The next thing I'm going to do is I'm going to go ahead and install our LEDs. Now I'm doing a green, a yellow, and a red, and I'm just kind of lining them up in the general area of the sensors so that I know which one is which. Now you may be saying to yourself, those are on the same rows as the infrared sensors, but each one of those rows is divided by that center median right there. Now, when I am putting these LEDs on the breadboard, I'm making sure they all share a common anode pin, which is the positive. And you know which one is which because the anode pin on the LEDs is the longer of the 2 pins. That will eventually share a 5-volt connection. Now we can start hooking up our wires, and we're going to start with the most basic one, which is to connect our 5-volt and ground to the little bus on the breadboard where you can see the red and blue lines. Now the black wire in this case is going to be our 5-volt, and the white wire is going to be our ground connection. And the reason I'm not using red and black is because we're going to be using red to indicate for the red LEDs for the signal. So black is 5-volt, white is ground. Next, we're going to wire up all of our LEDs, and we're going to be connecting it through the cathode or the ground connection. So these LEDs are sharing a common anode, so we need to connect it up separate. So I'm going to connect digital pin 2 to the LED for sensor 1. So that's going to be digital pin 2 is going to go to the green LED of sensor 1. Digital pin 3 is going to go to the yellow LED of sensor 1. And digital pin 4 is going to go to the red LED of sensor 1. Next, we're going to go ahead and do sensor 2's LEDs. We're going to take digital pin 5 and connect it to the green LED of sensor 2. We're then going to connect digital pin 6 to the yellow LED of sensor 2. And then we're going to connect digital pin 7 to the red LED of sensor 2. Now we're going to hook up our power to our sensors. They need a ground and a 5-volt connection, which on the sensors you're going to read as GND for the ground and VCC for the power. Again, black is the 5-volt connection and white is the ground connection. And the ground connection typically is the middle pin, and the 5-volt connection is going to be the pin on the right. We then do the same thing for the second sensor. Next, we're going to connect our sensors to the Arduino. We're going to connect analog pin A0 to the output pin of sensor 1, which is the pin on the left. And then we're going to connect analog pin A1 to the output pin of sensor number 2. The last thing that we are going to do is we are going to connect our 5-volt power to the common anodes of the LED. So the common positive, basically the pin that they are all sharing. So we're going to connect that from our breadboard 5-volt line to those LEDs, and we do it for both of them. Next up, I'm going to connect some wires to the ground to go out to the other blocks. They're not actually going to connect to anything right now because I'm just building this on camera, but these represent the common ground that all the Arduinos in the system need to share to be able to communicate back and forth with each other. Next, we need to hook up our send and receive pins. Now, for block A, that's going to be pin 8 for block A send, and for receive, it's going to be pin 10 for block A receive. For block B, that's going to be pin 9 for block B send, and that's going to be pin 11 for block B receive. Now the way these work is that since they're in order, the block A connections that go to the previous Arduino in the setup are actually going to connect to the block B one. So block A send is going to connect to block B receive on the previous Arduino, and block B send is going to connect to block A receive on the next Arduino. So those are all of the hardware modifications that you need to make. So let's go ahead and hop into the code and do some of the changes that we need to do there. Now I want to make this clear that I am actually going to be modifying the existing code from the previous project. I'm not going to be writing all the code from scratch. If you need that existing code to modify right here, I have a link for that in the description below, as well as a link to the fully upgraded code if you don't want to go through the whole process of doing all the adaptations. So what we're doing here is we're changing all of the signals and transmissions into 100% digital state. And what we're basically going to do here is the first thing we need to do is we need to change our receiving pins for the signal from the other blocks. And we're going to change those to digital pin 10 and digital pin 11, since we're doing 100% digital here. You don't need to mess with any of the other pins whatsoever. We are going to leave the sensors as analog pins. Okay, so now in our setup, we don't really need to do anything. Everything should still be set correctly. All of our states, we're not adding or subtracting any states. Okay, so this is where we need to do some changes. The first thing we need to do is for value A3, we need to change that to a digital read. And value A4, a digital read as well. And then that should be it for the main loop. Okay, so now we are at our first signal state. Now this is green, green, so both of them are green. And we don't need to do anything with the LEDs. The first thing we need to do is we need to adjust the block send commands. So first thing we're going to do is we need to change them to digital write for both of the block A send and block B send. And then we need to change their zeros to lows. So basically that's turning it into a digital write command where it's essentially not sending out anything, but it'll be read as a 0 on the other end. So now we have our changes in signal states where it's going to send it to a different state. So the first one's green yellow, which means that this one is going to be sitting unoccupied, but this one isn't. So first thing we're going to do is we're going to do double equal sign 0. And the reason that we do a double equal sign is because in Arduino language that means equal to. A single equal sign is kind of like is. So if you're saying it, if it's a single equal sign, it'd be value A3 is 0 versus value A3 is equal to 0. So and then we have value A4 is equal to 1 because block B would be transmitting right there. Next, we're going to kind of do the opposite for yellow green. So we do equal to 1 and equal to 0. And then we have our yellow yellow, which means that both blocks are sending. And that means that both of these are going to be equal to 1. And then the reds we don't mess with because we're not messing with any of the sensors. Now we have green yellow. So the first thing we need to do again is we need to change our analog writes to digital writes. And change those to low again because the block itself is not occupied. And now we just need to go through changing everything. Now we do have green green, which means they're both zeros. Then we have yellow green, which means it's going to be a 1 and a 0. And then we have yellow yellow, which is 1. Messed up a little bit there. Both of them are equal to 1. And then we don't mess with the value A1, value A2 for the reds. Now we can move on to the yellow green. So again, we need to switch the analog write on the send commands to digital write. And we're going to change those to low. Now for green green, equal to 0. This is just a lot of rinse and repeat, guys. A4 is equal to 0. Now we have green yellow, so we're going to do equal to 0 and equal to 1, and then we have yellow yellow, which of course is 1 and 1. So now we have yellow yellow. So again, we need to do the same thing. So we go digital write, change that to low, then do the second line, change that one to low, and then just, you guys know it by now, green green is equal to 0, green yellow is 0 and 1, and yellow green is 1 and 0. And then again, we don't mess with our reds. So that's all of the green and yellow signals that we're going to work on right now. So now we have our reds. Now the first thing that we're going to need to do, like always, is we're going to need to change our analog writes to digital writes. So we do that. Next, we have our block A send. Now we're going to change this number to high. And basically, that's just going to send out the full blast command where it's going to be read as a 1 by the other blocks that are going to be doing a digital read. And basically, this is going to be if this one changes and this one changes, we don't need to touch this. It's going to send it to that RR3. But we do need to go down to RR2 and change it to digital write. Basically, you're changing all of the analog writes to digital writes. And then that's kind of like coming in from the opposite direction, so that's RR3. And then we have RR3, we need to do the same thing. Change those analog writes to digital writes. And then change both the numbers to high. Like I said, those are transmitting. And then this will go straight to green, green. Now there is another modification that I want to make here. Now if you had downloaded the original sketch that's from that link, this would not have that. So what we need to do is we're going to go up and we're going to go back all the way to our setup. And we need to add another state. And what we're going to do, we're going to go st underscore yy1. And what that's going to do is basically we need another yellow state that shows that the block is clearing. So now we can go down to our states, and I'm just going to copy YY, and I'm going to put it in there and do it YY1. So that adds our additional state. So now the next thing I'm going to do is I'm going to copy the LED commands for YY. There's no sense in rewriting them by hand. So I went up to YY and I'm going to copy it down here, and I'm going to put that here. And then I'm just going to put a 1. Now the other thing we need to do here also is we have that YY1 right here. I do need to put a 1, so signal YY1. So now that will connect to this one right here. Now there's a few differences with this YY versus the other one. So what we're going to do is we're going to type in high and high because this shows that the block is clearing. And then that means that we can go now here and say that RR3, rather than going back to green, is going to go to YY1. So now we need to add in a few things to make what we're going to do work. The first thing we need to do is we need to go all the way back up to the integer declaration. So we're going to go int clear count. And this is our count for clearing the block. Next, we need to go to green, green. So we'll scroll down to green, green. And we're going to do clear count is 0. Remember, that's single equal sign right there. Clear count is 0. So that'll reset clear count whenever we need to. So now we can go all the way back down to our yellow 1, and we're going to start adding some if-then statements. The first one we're going to do is if value A1 is greater, whoop, misspelled there, is greater than 500, then we'll do a double ampersand for the and then we'll do value A2 is greater than 500, and clear count is less than 5,
You put that in parentheses. Then we're going to do a bracket. We're going to say clear count plus plus. And this will add 1 to our clear count every time it cycles through this if it's less than 5. Now we want this to be 5 seconds, so we need this to happen every second. So right now we have a delay of 500 right here. So what we're going to do is we are going to take that delay and we're going to change it to 1000 because it's in milliseconds. So we're going to change that, do that right there, and there is our clear count of 5 seconds of clear before it changes. Next, we need to do if value A1 is less than 500, or, which is what those 2 bars are, that is the / key, shift the / key right above your enter key. Value A2 is less than 500, and clear count is less than 5. Clear count is 0. And what that'll do is that'll reset our clear count in case of a false reading. And last but not least, we need to do if value A1 is greater than 500, we do our double parentheses, double ampersand for and, value A2 is greater than 500, double ampersand, clear count is greater than or equal to 5, signal state is equal to st_gg. So what that does is basically after 5 seconds of clear, it's going to switch it to green. And that is our entire addition right there. So YY1, I believe we have everything in place right there. Let's give it a run through. And there we go, we can go ahead and upload this. All right, we've got the hardware modified, we've got the code modified, so let's go ahead and give this a little test run. Now the way I have this set up is I have 2 other Arduinos with the sketch loaded onto it. I just don't have the LEDs connected on those. So we're only focusing on the middle Arduino. Now obviously you can see that when I test and I wave something over the infrared sensor of the middle Arduino, it goes to red showing that it is occupied, and then once I go over the second one, it goes to yellow. It's going to hold that for about 5 seconds, and then it's going to go to green. So now we're going to show the communication between all these, and we're going to start with this block. We're going to wave over one of the sensors to indicate that it's occupied. And you can see that the LED that's showing that the next block is occupied goes yellow. And then once we clear the block by waving against the other one, it takes about 5 seconds again just because of that clear check, and then it's going to go back to green. And now we can try the other block where we occupy that one. And you can see that the corresponding LED goes yellow. And now we go ahead and clear the block by triggering the second signal. It takes about 5 seconds. And now it can show back to green. Now let's show you what the progression looks like. We're going to occupy this block on the left first. You can see that the corresponding thing goes yellow, and then we show it begin to clear, but we're going to go ahead and say the train is passing into this block, which means that it goes to double red, which means that block's occupied. So now we're going to go ahead and go into double yellow as it exits the block, and it go ahead and occupies the next block, which means that it should hop to green and then immediately to yellow green, which it did right there. And then as the train exits the next block, it should take about 5 seconds and then go to green. And there you have it.
Well, there you guys go. The Arduino multi-block signal system has been improved and is now almost 100% digital. It still has the analog signals, which I'm probably not going to go away with just for several different reasons. But it's got digital communication between the Arduino blocks. So I hope you guys really enjoyed that. I know a lot of people have asked about implementing this system. So there you go, an improvement on the original multi-block signal system that should help it run a lot better. So thank you guys so much for watching. I want to say a big thank you to all of my patrons. They're listed right here. You can become patron for as little as $1 a month. A lot of behind the scenes stuff, a lot of things that you guys get to see, previews of what's coming up. I actually just did a state of the channel update showing them some of the behind the scenes stuff that's been going on. So thank you guys so much for watching. Until next time, I'm Jimmy from the DIY and Digital. Stay safe, be kind, and happy railroading. Hey everybody, it's Jimmy from the DIY and Digital and Hey everybody, it's Jimmy from the DIY and Digital, and today we're going to be doing stuff. Welcome back everybody. That thing has been in the shot the whole time.